Okay, so welcome back. Today we're going to start a new series where we're going to show you a really wonderful piece of free software called LabVIEW. And LabVIEW is important because in most industries on the planet, they need what's called data acquisition and control of equipment. And LabVIEW is a great way to learn about those processes, and it's also a piece of software that is used widely in the real world industrial community in many different areas. So it's a really great opportunity if you're going to be involved at all in engineering, electrical engineering, understanding control systems and data acquisition, which are used all around you. It's a really great opportunity to learn how all of that works. And we're going to talk about LabVIEW, what are the pros and cons of LabVIEW, how it works, and how you can set up some projects to do some data acquisition and control. And one example we're going to use, we have right here a project in LabVIEW, and what it does is it basically reads data in real time from a data acquisition device. In our case, we're using a Arduino, a very inexpensive $20 device that's coming into our computer over the serial COM port, the USB port, and here we've got it coming in COM6. And what it's doing is it is reading in real time every second whatever data is coming into one of the analog input terminals on the Arduino, and it will plot it on this chart. Now, one of the big benefits is what you can see here. Instead of writing code for your Arduino, and for example, like we do often on this channel in C#, having to write lines of code, this is more of a graphically oriented interface where you can basically drag and drop. Here we've got a chart control, we've got an analog read control, we've got a serial port control. You just drag and drop it, wire them up, and then run it. So you don't have to write code for your Arduino, you don't have to write a C# code, and it's a whole lot easier to simulate and design control systems and data acquisition systems. So let's talk a little bit about LabVIEW, why you should care about it, where it's used, and we're also going to talk about some of the pros and cons. As with anything in the real world, nothing's perfect. Everything has pros and cons, and in the engineering world, you need to be aware of both sides. So, as I mentioned, it's used for design, simulation, and learning about real-world data acquisition and control systems. And these systems for acquiring data and controlling equipment are used in virtually every industry: automotive, manufacturing, military, aerospace, energy, power, utilities, the power company. SCADA system, which is supervisory control and data acquisition systems, are used everywhere to monitor and control equipment. Basically, this is used everywhere you look. You may not be aware of it, but everywhere you look, there is some sort of control systems and data acquisition systems. And previously, I did a short series talking about control systems, what they are, the basics of how they work. I encourage you to take a look at that. But, when you get in your car, there's control systems. Manufacturing, they have control systems and data acquisition for running the manufacturing process. In airplanes, in the power company, it's basically everywhere. So if you're interested in engineering, and especially electrical engineering, it's really important that you get familiar with these systems. And this LabVIEW is a great way in order to do that. So the hardware involved with control systems, some things you might hear about, are network communications. Basically, you're tying together a bunch of different components, data acquisition components and control components. So there will be communications between all those different components. There's what's called programmable logic controllers, or PLC, where you can take data and cause things to happen using a programmable logic controller. Data acquisition devices, or DACs, which is basically like an Arduino. In the professional world, there's other manufacturers of more expensive data acquisition devices. You'll see sensors, temperature sensors, fluid sensors, all kinds of sensors, motors that are being controlled, monitoring the speed of a motor, and you control it, valves, and so on. So there's a whole lot of hardware involved, and this is a great opportunity to learn about data acquisition and control of all those different types of hardware. So now let's take a look at the pros and the cons of LabVIEW. And as with anything in the real world and the engineering world, you need to be aware of both the positives and the negatives so you can really evaluate it and decide whether it's for you or not. So the biggest pro in my view is that it is free for non-commercial use. So you can download it with most or all of the functionality and you can use it as long as it's for non-commercial use. And another thing that it's free to do with LabVIEW, and that's quite a bit different as I recall from MATLAB and Simulink. In LabVIEW, you are free to create applications or executables, .exe files, to run your projects that you generate in LabVIEW. You can run that on other machines that don't have LabVIEW installed. So it's really nice. You can generate a project in LabVIEW, create an executable, put it on a thumb drive, bring it over to another computer that doesn't have LabVIEW, and it can do data acquisition for you using your LabVIEW project. Really wonderful. So again, as we said before, it's used in many industries. And for many people, a really big positive is it's graphical rather than text-based. You don't have to write lines of code. You just drag and drop and wire up the different components. Now, it also works with data acquisition devices like Arduino, the Raspberry Pi, and of course, commercial data acquisition devices, especially from National Instruments, who provides LabVIEW, and they also have a big line of commercial data acquisition devices. And of course, LabVIEW works with those and other data acquisition devices by other companies. Of course, those will probably be limited to some extent. And another big one is you may not need to write an Arduino sketch. If you hook up an Arduino to this or a Raspberry Pi, you may not have to write a sketch. This will be built in and it will do it all for you. Same thing with like a LabJack. If you're familiar with another data acquisition device in the commercial world called a LabJack, it's really quite easy to interface with that and you don't have to write any special code in C# or whatever. So a lot of really good positives. So now, as with everything, there are also cons. What are the cons or some of the cons with LabVIEW? Well, it does require learning a totally new approach and a new set of tools. And sometimes the tools can get kind of complex and difficult to understand, but thankfully most of the time it's really fairly easy. Just drag and drop controls and wire them. However, it can be more complicated and take longer than, for example, if you're going to write C# code to do something, some data acquisition or control. And we're going to take a look at that coming up here. Also, it may not provide the required customization that you get if you write the code from scratch in C# or Python or whatever. So that's something to consider, though you may not need the customization. Now, one of the big things to keep in mind if you're working in the commercial world, National Instruments, or Emerson, no longer supports what turns out to be one of the most popular industrial communication protocols called Profinet. So they have stopped supporting that. So you may have some challenges if you're using that. And also, the support for some other protocols, communication protocols, is limited. May not communicate with or support other manufactured devices like Ethernet/IP, EtherCAT, and so on. So you do have to be careful if you're working in a commercial world, what you can support with this National Instruments LabVIEW. So keep that in mind. Also, it no longer supports Mac OS. It does support Windows and Linux, but not Mac OS. So there are some cons here that you need to be aware of, and I'm sure there are more. But just keep in mind, nothing is perfect. And in the real world, you need to be aware of some of the downsides. So now here is a really simple example using LabVIEW, where, as you can see on the right, I've got an Arduino Uno connected via USB to my computer. And on the A0, the analog input, I have connected my DC power supply. And what I'm going to do is I'm going to show you basically just grabbing the value coming from the DC power supply into the Arduino and plotting it. So I'm going to hit the run button up here. And you can see it's bouncing around 0 to 0.02 volts. And what I'm going to do is I'm going to adjust the power supply. You can see it being charted in real time every second on this plot. So you can see we got some real-time plotting of data coming directly from the Arduino. And in order to do this, I don't have to write any code. This is kind of similar to what you would see in the C# Visual Studio Windows Forms application, where I've got our form. In LabVIEW, it's got what it's called a control panel, which is like a form in C#. And the code is, instead of lines of code, it is this graphical drag and drop interface. And if you're familiar with Simulink with MATLAB, it's very similar, where you have kind of modular or object-oriented objects that you drag and drop, and then you wire them up, and you hit run, and it will actually run whatever you have configured. And here I've got the Arduino coming in on COM6 through a serial port. And this rectangle object is a while loop that keeps this running indefinitely until I hit the stop button. And you can see I've got the waveform chart, and I've got my timer. So all of the stuff that you would put in C# code are now in LabVIEW. You can do it graphically and just wire it up. So really a wonderful way, especially when you got more complicated systems that you need to model, it's really a wonderful way to do your analysis. However, in the real world, you don't use the same tool for every job. And while it might seem like a very nice concept, that doesn't mean you're always going to use the LabVIEW graphical interface. And what we're going to do is we're going to compare making a very simple application in what you see here, C# Visual Studio Windows Forms, versus how you would do it in LabVIEW. And you may, at the end of the day, decide, well, maybe this is something I might want to do in C# or whatever programming language. And the graphical interface really doesn't help me, and it can be kind of confusing and can take a long time. So what we're going to do is we're going to write a very simple application. We're going to call this a state machine. And this is kind of in response to a video I saw someone post about LabVIEW, making a state machine program using LabVIEW. And it occurred to me, boy, that would be so much easier if we just did it in C# Visual Studio. And the state machine here is basically you're simulating throwing dice. And each time you press this button, it's going to generate a new random number between 1 and 6, which is as if you threw a dice. And it's going to print the number here in this text box, and it's going to chart it in this chart. And I'm going to hit throw dice, and it gave me a 6. I do it again, it gave me a 5, a 1, a 2, a 3. So it's just generating random numbers each time I throw the dice. And if you think about how you can do this in C# Visual Studio Windows Forms, if you have any experience with that, you know this is going to be pretty easy, right? You just have a button here, a text box, and a chart. When you press this button, you have an event handler that generates a random number between 1 and 6, puts it here, and then adds it to the chart. Now, you may know, if you worked on charts in C#, that it can be quite a bit of work to configure the chart so that it's, as we show here, which is a line chart with these markers and so on. But what we'll do is we will compare that to how you would do something similar in LabVIEW. So here is the code in our C# Visual Studio Windows Forms. And honestly, it took me less than 15 minutes, maybe 10 minutes to generate this. I've got the design, which is a text box, I've got a chart, and I've got a couple buttons. And all I've done is I've got an initialize chart method, which really takes the most amount of time. So when I start up the form, I do initialize chart, which says it's a step line, which is a line chart in steps, so it doesn't interpolate. And the width of the line, it's a circle marker style with a size 12. And then I set the minor grid enabled is false on the y-axis, and it goes from minimum to maximum 1 to 6. And then that's about it for setting up the chart. And the only work that's being done, I've got a couple of properties here. Dice value, I'm starting at 0, and an increment, I'm starting at 0. So each time I click the button, I'm going to have an increment, so I can have numbers to chart on the x-axis of the chart. But basically, button 1 click is the only code I need. I have my increment. I'm incrementing that each time I press the button. I do a new random number, and each time I do random.next, a number between 1 and less than 7, which means 1 to 6, is my value. And then I just put that value, whatever I get, to string on the text box, and then add it to the chart1 series, points, add, x, y, the increment, which increments each time, and then the dice value. And that's it. Very simple, straightforward. If you have any experience with C#, you know you can put this together very quickly. Now let's take a look at how we would do the same thing in LabVIEW. So as we showed in our C#, we've got our main form called a front panel in LabVIEW, and I've got a button, I've got a basically a text box and a chart, and I've got a stop button to stop it. So pretty straightforward. However, this is the graphical equivalent to this very simple code we wrote. And if you can take a look at this and you can understand it, well, good for you. But a new person looking at this, yes, it's graphical, but it is really kind of confusing. We've got a while loop in this square. Inside that, we've got a case structure, which turns out is a kind of like a switch case statement in C#. Then we've got an event structure. We've got event handler. We've got a throw dice value change. We've got shift register, next state initialization. So you can imagine that you need to learn a whole different universe of concepts in order to implement what is fairly simple if you're familiar with C# or Python or whatever. So again, as with anything in the real world, you don't use the same tool for every job, and learning LabVIEW is fine, but you may not want to use that in every task. So in the next video, we're going to show you what steps you need to go through to download the free, what's called the community version of LabVIEW. And thankfully, it's all set up pretty much for hobbyists. I assume most of the viewers on YouTube are hobbyists. So it's got a lot of things configured already for like an Arduino. So you're all set to go. After that, we'll show you how to generate this project here, which actually reads from an Arduino and does a chart. And we're also going to show you the steps you need to do to download and install the software you need to access another professional grade data acquisition device, and that's called a LabJack. And LabJack is another very popular data acquisition device. We're going to show you how to download the software to operate that. It's kind of like an Arduino, but a professional version with protection on the inputs, and it's got wider ranges and so on. So we're going to show you how to do something similar with a LabJack and also an Arduino. So if you're liking these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.